All right, guys, sorry I didn't get this done a day earlier, but this is your trig identities. This is on a blue paper, and your paper will have thetas instead of an x here, but I'm going to get these filled in real quick. So sine is 1 over cosecant x, cosecant's 1 over sine x, and honestly, you should be able to fill these in really fast. And you do have to have these memorized. So as I'm filling them in, I am explaining a little bit as I go. I will tell you that 1 over cotangent x, these two down here are rarely used. I'm going to put frowny faces by them because they're just not used very much. They can be used, and they can be useful here and there. You just have to look ahead and see which one's going to help you. What you will use a lot are quotient identities. Tangent is sine x over cosine x, and cotangent is cosine over sine. These two you use a lot. Now the quotients in squared is just everything again, but just put a squared to it. So cosecant squared x, and this is 1 over sine squared x, and so on. And tangent is sine squared x over cosine squared x, cotangent, and you know what I didn't do? I didn't do the squares. The squares have to go in there. Okay, and then you can finish filling those out. I just want to keep going real quick. This is, these are a few things on how to simplify. Factoring we'll do a little of that later. We will definitely be rewriting identities. One thing we have to do is avoid trig functions in a denominator. Leave sine and cosine alone. In other words, don't change those into 1 over cosecant, 1 over secant, okay? All right, so let's see some use of the identities. Cosine, I'm going to leave alone, so I'd rewrite cosine theta, and then secant becomes 1 over cosine theta, and when one's on top, one's on the bottom, these guys cancel, and that just leaves you 1. This one is 1 over cosine. I had to stop and think about it, sorry. Cosine is, or cotangent is cosine over sine. And cosines cancel, leaving 1 over sine theta. And 1 over sine is cosecant. I have to have a final answer, and that's it. Sine times cosine over sine, and thetas, of course, are attached. These cancel. It just leaves me cosine theta. I have cosecant, which is 1 over sine times cosine theta, and you're welcome to put it over 1 if you like. That gives you cosine over sine, which is tangent. And that's my final answer. Cosine theta times sine over cosine. These cancel, and that gives me sine theta. Final answer. This last one, it's cosine over sine times 1 over cosine times sine itself. Now look what cancels, and thetas need to be filled in, something I always leave out. Cosines cancel, and look at the sines, they cancel. All of this went down to 1. All right, next one, we have cosine times 1 over cosine times cosine again. The cosines cancel, and it doesn't matter which two cosines you cancel, it leaves you one of them. Cosine theta's final answer. Tangent is going to be Now there's two ways to do this. You could go ahead and distribute this first and get tangent times cosine minus tangent times cosecant. All right, and then go back and fill in everything that everything is equal to. So tangent is sine over cosine times cosine. Those cancel. Minus sine over cosine times 1 over sine. The sines cancel. That left me sine theta minus 1 over cosine theta, which I don't want to leave this in a denominator. So I'm going to rewrite that as sine theta minus secant theta. And that is as small as it will go. All right. One more page and I'm going to take a break before I show you the next ones. All right, so when they're stacked up like this, these are divisions and we keep, change, flip. That's what KCF is. So cosecant theta divided by cotangent theta is going to be 1 over, 1 over sine theta. I was just double checking myself, sorry. Divided by cosine over sine theta. Okay, now this is where I keep, change, flip. So keep, change, flip. The signs cancel. I'm left with 1 over cosine, which is the same as secant. There it is. All right, so tangent. Now you could go ahead and say tangent is sine over cosine, and they're squared, divided by sine squared theta over 1, right? Because that's all it is. And then I'm going to keep, change, flip. Sine, whoops, these were supposed to be squared. Sine squared theta over cosine squared theta times 1 over sine squared theta. That was keep, change, flip. The sine squared thetas go away. Leaves me 1 over cosine, which is secant squared theta. Final answer. Okay, this one, secant is 1 over cosine theta divided by cosecant is 1 over sine theta. So if we keep, change, flip, it's going to be 1 over cosine times sine over cosine, or sine over 1, excuse me, which gives me sine over cosine, which is equal to tangent theta. Final answer. Number 12 is sine theta plus tangent is sine over cosine. You use sine over cosine 90% of the time. The other 10% you will use 1 over cotangent, but just not too often. Okay, my cosines canceled. That leaves me sine theta plus sine theta because these became 1s. So that gives me 2 sine thetas, not sine squared theta. Be careful. Final answer. Okay, I'm going to take a break and I'll show you how to do the other in a minute.